Hello students, this is the problem number 4 in formation of Y-bus using singular transformation method. The problem is, for the network shown in figure, obtain the Y-bus with node 1 as a reference using singular transformation method, neglect mutual coupling, self-impedance of elements are marked on the diagram, are in per unit. This is the given network. Here we have 4 nodes and 4 elements. Okay, self-admittance elements are given here. Self impedances are given. Okay, so this is a graph, so we have to convert from graph of the network to oriented graph where the elements are assigned with the directions. Okay, so here I am going to draw the diagram as it is. Now I am going to assume the directions. Okay, so let it be away from the reference node, so you can take right side, no problem. Okay, you are going to get the same answer. Okay, final answer would be same, but if you are taking like this, you are going to get the each and every step answer as I get here. Okay, so from 1 to 2 and 1 to 4, 1 to 3, 4 to 3. This is the first element, this is second element, this is the third element, this is the fourth element. You can take randomly, no problem. Okay, so what we have to do is, first we have to calculate first we have to find A cap. Okay, we have to find A cap. From A cap we have to get A. From A we have to get A transpose. Then using Y we are going to form the Y bus. Okay, Y bus is equal to A transpose Y A. Okay, so we'll form A cap. Okay, element versus node. 1, 2, 3, 4 nodes are there. First is a reference node. 1, 2, 3, 4 elements are there. Okay, just look at the diagram here. First element is away from 1. Okay, towards 2, and it is not oriented to 3 and 4. Second element is away from 1 towards 4. Okay, and not oriented 2 and 3. Third element is away from 1 towards 3. Away from 1 towards 3. Okay, and fourth element, which is away from 4 towards 3. So this is the matrix. Next, in order to get A from matrix A cap, we have to delete column corresponding to the reference node. Then A will be -1, 0, 0, 0, 0, -1, 0, -1, 0, 0, -1, +1. Okay, A transpose, it would be -1, 0, 0, 0, 0, 0, -1, -1, 0, -1, 0, 1. Okay, now we have to form matrix Z. From this matrix Z we have to form Y, because it is given self impedance of the elements are marked on the diagram. So Z11, it is 0.1, 0, 0, because it is a self impedance matrix. Okay, and 0, 0.2, 0, 0, 0, 0, 0.25, 0, 0, 0, 0, 0.5. Okay, we have to convert from Z to Y. Y is equal to inverse of 0.1, it is 10, 10, 0, 0, 0, 0, 5, 0, 0, 0, 0, 4, 0, 0, 0, 0, 2. Okay, now we have to convert from A transpose and A and Y to Y bus. Y bus is equal to, okay, Y bus is equal to A transpose, okay, we'll write in another sheet. A transpose Y bus is equal to A transpose, which is minus 1, 0, 0, 0, 0, 0, minus 1, minus 1, 0, minus 1, 0, 1. Okay, and Y bus, which is 10, 0, 0, 0, 0, 5, 0, 0, 0, 0, 4, 0, 0, 0, 0, 2. Okay, and matrix A minus 1, 0, 0, 0, 0, minus 1, 0, minus 1, 0, 0, minus 1, plus 1. Okay, take first row and first column, multiply here, you get the matrix, the value will be minus 10, okay, minus 10 and 0, 0, 0, second row with first column, 0, 0, minus 4, minus 2. Okay, third row with first column 0, third row with second column minus 5, third row with third column 0, third row with fourth column minus 2. Okay, into minus 1, 0, 0, 0, 0, minus 1, 0, minus 1, 0, 0, minus 1, 1. Okay, now first row and first column plus 10. Okay, first row with second column 0, first row with third column 0, second row with first column it is 0, second row with second column 4 plus 2 it would be 6, minus into minus plus 6, second row with third column it is minus 2. Okay, third row with first column here it is plus 2 because plus 1 into 2, here is 0 into 0 0, minus 1 into 0 0, 0 into 0 0, 1 into 2 plus 2. Okay, so when you take third row with the second column it would be minus 2. Okay, it is minus 2, and third row with third column it is 0 into 0 0, minus 5 into minus 1 plus 5, 0 into 0 0, plus 2 into plus 1 it is plus 2. So 5 plus 2 it is 7. So this is the matrix Y, this is the matrix Y bus using singular transformation method. Thank you.